How are you, grade 10? I hope you're fine. Today we're going to complete our lessons in the fourth quarter. Today's lesson in chapter 9, lesson 9.3, rotation. Of course, in the last two lessons we took the first two types of transformations, which are reflection and translation. Okay, and we said that the reflection, I must have a line of reflection. Okay, and the figure flipped around this line. And we said about the translation that the figure translates from a place to another. Here in the rotation, what's rotation? Let's remember what's the rotation. Rotation is a transformation that turns the figure. So the figure, what will happen to the figure? It will turn. In the reflection, it's flipped. In the translation, the shape is the same, but it moved in a direction. What about rotation again? Rotation turns the figure, okay? Turns the figure around a fixed point. So I have a fixed point, around a fixed point, called the center of rotation. A rotation is isometry. Do you remember the word isometry? The word isometry means the shape and the size keep without changing. So no change for the shape or the size, okay, of the figure. So the image of the rotated figure is congruent to the pre-image, okay? So the image is congruent to the pre-image. Look here. Which one of this have a point and the figure is turned from this point here? I have a point here, and the blue figure is turned to be the red one. So this is what? Rotation. What about this? The figure is flipped around. I can draw a line here in the middle, which called what? Reflection line, or line of reflection. So this is reflection. It's not rotation. Okay, very good. Let's complete. The rotation is transformation about a point B called the center of rotation. Okay, so if I want to rotate the point A and I get its image A dash, I will rotate A about the point B. So B will be the center of rotation. Again, center. Do you remember what center is? Center, that means as I'm going to make a circle. Center means I'm going to make a circle. Okay? Very good. Do you see this direction? What's this direction? It's counterclockwise. And take care of this hint, unless otherwise stated, all the rotation in this book are counterclockwise. So all rotations are counterclockwise. Very good. Or anti-clockwise. Such that each point and its image are the same distance from the B. Okay? Again, B is the center of rotation. So as I'm going to make a circle. Okay? So the distance between the center of rotation and the point, the original point, equal the distance between the center of rotation and the image. Okay, the two distances here are equal. Okay, very good. And such that all angles with vertex B formed by the point and its image are congruent. So I have here, what is my angle of rotation? The angle of rotation is AB A dash. Okay, so this angle is called angle of rotation. Again, we said about the reflection. We said about the reflection before that I need a line of reflection and the figure flip. And in the translation, we said that the figure moved, okay, in a direction of the vector. Here in rotation, the figure turns in a certain point, about a certain point. This point is center of rotation. This center of rotation, okay, the point will rotate counterclockwise, and its distance from the center of rotation equal the distance from the center of rotation to the image. Okay, and this angle is called angle of rotation. So the rotation needs center of rotation and angle of rotation. Again, the rotation needs center of rotation and angle of rotation. Reflection needs what? Reflection needs line of reflection. Very good. Translation needs what? Magnitude and direction. Remember, magnitude and direction. Rotation needs what? Rotation needs center of rotation and angle of rotation. Okay, of course you can revise the two lessons before from the videos on the YouTube channel. Okay, SIS, Sunrise International School. Okay, how to draw rotation. If he give you a figure like this and he tells you to rotate this triangle about the point B with the measure of angle A, you're going to measure this angle A, and if I measure it and it's 50 degrees as an example, what I'm going to do, I'm going to take from the point here to all vertices of the figure. I'm going to connect between this point to the vertices of the figure. Okay, then after connecting, what I'm going to do, we're going to construct an angle congruent to A. So this is 50, I'm going to construct 50. Okay, starting from where this is the side of the angle. Okay, this is the side of the angle, and I'm going to measure 50 till I make the other side. Okay, very good. Then I'm going to put the point, and at the end I'm going to connect the vertices of the figure together to connect and make the image. Okay, very good. Let's see here. This is the important part in the lesson. Yani this part which drawing, you're not going to draw. You just need to know, but you're not going to draw it. Okay, here you're going to use this in the coordinate plane. So important. In the coordinate plane, rotation in the coordinate plane by 90 degrees above the origin. My point always the origin. My point here always the origin. Okay, here always also the origin. But here it's 90 degrees and here 180. Okay, I have here the rule of rotation, that my point is x and y. It will be negative y and x. Okay, negative y and x. This is my transformation. If I'm making 90 degrees about the origin, if I'm making 180, my point xy, it will be negative x and negative y. Okay, negative x and negative y. Okay, very good. Let's take this example. If you want to rotate A, B, C, and of course I told you you're going to plot the points on the coordinate plane. Here 2 and negative 1. 2 and negative 1 is A. B 4 and 1. C 3 and 3. Okay, then what we're going to do, he told me rotate by 90 degrees above the origin. So what's my rule? Negative y and x. Negative y and x. Here, where is my y? This is x and this is y. So negative y, negative 1 is 1, and x is 2. Very good. So this is the image. Let's see B. Negative y, which is negative 1, and x, which is 4. Negative y, which is 3, negative 3, and x, which is 3. Okay, so I get the points by my transformation here. The rule of rotation. Again, the rule of rotation by 90 degrees above the origin, that negative y and x. Negative y and x. Very good. After I get the points, I'm going to plot it on the coordinate plane and connect them. Okay, so I'm graphing the pre-image and the image. Okay, that's easy, so easy one. Okay, let's continue. What if, here, take care of this, if the angle of rotation in the coordinate plane is not multiple of 90? We can use sine and cosine ratios. How? Let's see this. Exercise is so exciting one. The London Eye observation wheel has a radius of 67.5 meter and takes 30 minutes to make a complete rotation. Okay, complete rotation. The starting point here, I return to it again. So this is the complete rotation. A car starts at position 67.5 and 0. So this is ordered pair of the car, of the position of the car. What are the coordinates of the car's location after 5 minutes? After 5 minutes. Here we said a whole rotation from the starting position to return it back, it's 30. But here it tells me after 5. Okay? So 5 over 30, it's what? It's 6. 1 over 6 of the whole rotation. It's 1 over 6 of the whole rotation. So we're going to find the angle of rotation. It's 5 minutes. Then 5 over 30 is 1 over 6 of the complete rotation. Okay, we know that the circle is 360 degree. Starting from here, then returning back, it's 360 degree. Here, starting from here, then returning back, it's what? 360 degree. Okay, so I want fix 360 degree, or 360 degree divide 6. It will give you what? 60. Very good. Then what after this? I'm going to draw a triangle because I'm going to use the trigonometric ratios. Okay, perpendicular here. I'm going to make a perpendicular here. Of course, this is the starting point and this is the ending point. Okay, this is the new position of the core. And take care because this is part of the circle. So this is a radius, اللي هو 67.5, and this is another radius. Okay, so this also 67.5. Okay, very good. Then I'm going from here, I'm going to make perpendicular on the horizontal line here. Okay, and we get the angle, it's 60 degree. How we get the angle? That we said that all is 30 and this is only 5, so 5 over 30 is 6. 6 of the 360 is 60 degree. Okay, okay, very good. So this is 60. So this triangle, this right angle triangle is 30, 60, 90 degree. Okay, remember 30, 60, 90 degree. Very good. I'm going to use the cosine ratio to find the x coordinate. I'm going to use to find the x coordinate. Okay, here cosine 60. Cosine equals what? Remember, adjacent over hypotenuse. Adjacent over hypotenuse. Adjacent, which is the part that I don't know, which is x here, which is x. Okay, over the hypotenuse. Then I'm going to get it by the calculator. Then I'm going to use the sine ratio to get the y coordinate. This part, the y coordinate. Okay, I'm going to get sine 60, this is the y. Sine 60 equal y over 67.5. What is the sine, do you remember? It's opposite over hypotenuse. Opposite over hypotenuse. Then I'm going to make cross product. Okay, and solving to get the y. So the core's location after 5 minutes, this is its x, and this is the y. I get it how? From the triangle here. Easy? Okay. Okay. Okay, this is for now. We're going to complete the solving exercises and practice book next session. Thank you, grade 10. See you next